This is Chapter 9, C, Formatted Input and Output. And we've already been working with these format specifiers, so a lot of this will be something we're seeing, but they'll use it differently. In this chapter, use input and output streams, use all print formatting capabilities, use all input formatting capabilities, print with field widths and precisions, use formatting flags in a printf format control string, output literals and escape sequences, and format input using the scanf. And these are just the different sections of that chapter. Okay. Introduction. Important part of the solution to any problem is the presentation of results. Sometimes when you print off your results, it'll give you something that has 10 decimal places. And maybe it's supposed to be in a dollar format where you only have 2. Well, looks bad with all those decimals in there. In this chapter, we'll discuss in depth the formatting features of scanf and printf. These functions input data from the standard input stream and the output data to the standard output stream. And you need your standard io.h header, the ones that call these functions. We talked about streams before. You got data coming in. It's coming in like a stream. Data's going out. It's going out like a stream. Specifically, a stream of bytes. So data's going out in pieces or coming in. Input, they're flowing in. Output, they're flowing out. Program execution begins. Three streams are connected to the program automatically. Normally, the standard input stream is connected to the keyboard, and standard output stream is connected to the screen. So that goes there by default. So when you do a scanf or you do a printf, then it goes to those devices. Operating systems often allow these streams to be redirected to other devices. I think I showed that in Linux a little bit, right? Where you could redirect your output into a file. I'm not sure if I showed that. But we'll see that. That's actually later in the book, where we'll take the output and we'll send it into a file. So you can redirect them to other devices. Linux especially makes it easy. It's a little bit harder to program in in like a Windows environment. When you do the Linux side, where it normally goes to the screen, actually let me show that. It'll make more sense, I think. The same principle kind of applies when we're talking about Windows to a certain extent also. But it just doesn't as powerful as Linux. For example, if we do a ls, that prints our files. If I do an ls greater than my output.txt, we don't see anything because it took all the stuff that would have went to the screen and wrote it to the file. And so if I do a cat output or cat my output.txt, you see that went to that file. Now it doesn't have its formatting. I really don't know how you keep the formatting. It just seems to always lose it. But that's what it's talking about. It's so easy to redirect whatever normally went to the screen to your file. Now there are exceptions to that. Like if I do an ls, see if I can get the syntax correct on this, -r slash greater than bigfile.txt. The ls is list files, and the -r, uppercase R, is recursively. So it'll go through all the folders underneath each folder. So, and then the slash is your root. Now, if I redirect that to the bigfile.txt, I still get messages appearing on my screen. This is kind of what they're alluding to over in that PowerPoint, is that there's, in Linux anyway, there's like the normal display that goes to your screen, and then there's error messages, and you can redirect the error messages to a file also. So that's your, if you when I was saying, well, it has 3 connected automatically, what does that mean? Well, it's a reference to Linux. I don't think Windows does have 3 automatically. I might be wrong. Okay. Let's see. That's our streams. Precise output format is accomplished with printf, which you've seen. You need a format control string. It can do conversion specifiers, flags, field widths, precisions, literal characters. And together, percent sign these form the conversion specifiers. We've seen those already. %d for decimal integer. Function printf can perform the following formatting capabilities. You can round, line the number of columns with decimal points appearing one above the other, right justification, left justification, insert literal characters at precise locations in a line of output, representing floating point numbers in exponential format, representing unsigned integers in octal and hex format, and displaying all types of data with fixed sized field widths and precisions. They keep talking about what they're going to do, but okay. Here we are down here with our conversion specifier. So print integers. Do printf %d/n, and then my test num. That we've seen already. Just prints 3. We got %i, display as a signed decimal integer. Note the I and D specifiers are different when used with scanf. So that won't do us any good in showing it in printf. Display as an unsigned octal integer. Well, let's see what in the world that does. Printf %o, I think is what it was. Test num. 3. If I put 9 in here, and then run it, we get 9 and 11. 11 is octal. Have you seen those? You haven't? Yeah, let me see if I can grab my pen. I forget where you said you're going. You're going to Wichita State?
UCL.
UCL. Okay, they probably don't have the same program as Wichita State, so you may not get into this in much depth. But it's good to know, because machines represent their data in different formats. If you're going the computer science route, at some point you will have to know this. Maybe. No light. I wonder what that means. I can do it with a mouse, but it'd be easier with the tablet. Try this tablet. I need to order a new tablet. I just haven't got around to it. Nothing. Well, let's see if it's adding the software. I'll go ahead and do it by hand. Now, octal. First off, decimal is what we're used to working with. 35, for example. Octal. Cool. Octal is the digits. Well, first off, our decimal. Goes from 0 all the way up to 9. This is base 10. There's 10 digits. Octal goes from 0, 1, all the way up to 7. There's 8 digits. Including the 0, there's 8 digits. These are the only digits you can use to represent octal. And the problem I chose was 9 in decimal, base 10. So I'll put a D there for base 10. Now to change that to octal, you look at your digits here. This first spot here is 8 to the 0 power, which is 1. This next spot is 8 to the first, which is 8. This is 8 squared, which is 64. This is 8 to the third, which I have no clue what it is. Okay, forget that one. I don't need it that high. Since my number is 9, I look for the first number that's less than or equal to that number. 64 is not it. So I could put a 0 here or leave it blank. This one is the first number that's less than or equal to that. So what I do is I do division. I'm going to take my 9 divided by my 8. That gives me 1. And this is old style division. 1 times 8 is 8. Subtract them. And this is your remainder. So this would be a 1 here. And then you take your remainder and you look for the next number that's less than or equal to that, which in this case is a 1. 1 divided by 1 is 1. 1 times 1 is 1. Subtract that, and you get 0. And this is our remainder, and that's 11. So 9 in base 10 is equal to, all right, so we see octal. Is 11 an octal. Is that I'll do a harder example because that one's kind of, let's see. 64 is about as high as I can go, though. So let me choose like a 50 or 100. I think 100 will work. Okay, so we got 100 in base 10. And if I do my blanks again, this is always 8 to the 0, which is 1. This is 8 to the first, which is 8. This is 8 squared, which is 64. So I'm looking for the first number that's less than or equal to this, which would be the 64. So you take 64 and divide that into 100. That goes once. 1 times 64 is 64. Subtract that, and we get 36. And this is my remainder. So we put a 1 here. And now we're looking for the next number that's less than or equal to 36, our remainder, which would be 8. 8 goes into that 4 times. 4 times 8 is 32. Subtract that, and that's our new remainder. And that 4 goes right here. Then my next number that's less than or equal to this is the 1. 1 goes into 4 times. 4 times 1 is 4. Subtract that, and we get 0. You should always go to 0 at the very end, if not before that. So then this 4 goes here. So 100 in base 10 is equal to 144 in base 8, or octal. Now, where this is used at, probably nowhere. Octal is not as popular for networking as hex. If I do an IP config, and I'm forgetting what it should be, /all. And I want to do pipe sign more, but I know that's Linux. Maybe I didn't want all. But you see this address down here. This is in hex. And so they use hex a lot with networking. How many times you have to convert back and forth, I don't know. But you see it a lot on the networking side. So let's talk about that. Let's see. If I had 100, again in decimal, and I want to convert to hex. Hex is the same idea. You start with the 0 power here, so 16 to the 0. This would be 16 to the first, and I think that's as high as I can go. 16 to the 0 is 1. 16 to the first is 16. I think that's 256. But it doesn't matter because it's greater than 100, so I can't use that one anyway. So to convert this then, you look for the first number that's less than or equal to it. And that's not 256, that'd be 16. And you see how many times 16 goes into 100. 5, 6, 6, I think. 6 times 6 is 36. I'll put the 6, carry the 3. That's 96. Subtract that, and we get 4. So this has a 6 here. And then I take my 4, and my next number is 1. 1 goes into 4 times. 1 times 4 is 4. Subtract that, we get a remainder of 0. So this would be 4. So this would be 64 in hex. The idea is, and it means a lot more as your numbers become bigger. You don't see the power of it here, but you can represent the same number with less digits. The hex goes 0, 1, all the way up to 9. Now, hex means base 16. So now the next number is 10, but that's not a single digit, is it?
So you represent that with A?
With A. 11 would be B. 12 would be C. 13 would be D. 14 would be E. And 15 would be F. So for base 16, you cannot have anything above F. Because, remember, it starts at 0. So there's 10 there, and then there's 6 more there, so it's 16 total. So that's your 16 digits. So if I had come up with a 10 here, instead of putting 10, I'd put an A here. And so that's why you see, well, I must have closed it. I don't see the window. But that's why you saw those letters, and you didn't see any above an F. You'll take probably in your computer science program, you'll take a discrete math, discrete structures class, and you'll see a lot of this. So. Unfortunately, I didn't keep track of what I wrote down. But let's change it to 100. And so I come over here, I'll change this to 100. And let me look up the format specifier for hex. I'm guessing %H, but let's go see what it says. I don't have memory. Hex. Yeah, that makes sense. It really does. I'm not because you'll see in a lot of places, like assembly language, you have to it starts with 0x and then has a number. That 0x indicates hex. So that makes perfect sense that it'd be an X. Okay, so if I run that, you see how we get 64 for hex. And octal is the 144. Now going backwards, this first digit here is 16 to the 0. This is 16 to the first. So you take 6 times 16 to the first plus 4 times 16 to the 0, and that should give you 100. So it's easier to go backwards. This is actually kind of useful if you're taking one of those classes where you have to convert numbers back and forth. Mind you can do it on some calculators, and you can probably do it on Google, convert it, but you could write your own program even. Okay, so %O, U is unsigned decimal integer. HL or LL placed before integer conversion and indicates short long or long integer is displayed. Length modifiers. %U, what is %U? Unsigned. And if you pass in a negative to an unsigned, this says it's interpreted as this unsigned value. Kind of radically different, isn't it? So I think they're putting that there just to emphasize you need to be careful on these, because if it's not supposed to have a sign and you declare it with a sign, then if you use that %U, you'll get wrong results sometimes. If it's a positive 455, I'm guessing it'd print 455. But since that negative, it screwed it up. There's a error they're talking about. This is what a lot of those assignments in the back are doing, is just having you print every different kind of specifier and see what it looks like. This down here is hexadecimal with lowercase letters. This is with uppercase letters. And that's why here you get these. Now, if you're wondering, what does 1C7 equal? 1C7. And I wrote that wrong. 1C7. This is 16 to the 0 power. This is 16 to the first. And this is 16 squared. So this would be 1 times 16 squared plus C times 16 to the first plus 7 times 16 to the 0. So this is 1 times 256 plus C. C. Well, I'm having more trouble with these. A is 10, B is 11, 12. So that's 12 times 16. And 16 to the 0 is 1. So that's 256 plus 192. So we had to make a basic math mistake. Plus 7. 8, 15, 10, 15, 2, 3, 455. Yeah, 455. So that's doing the conversion for you. I was doing this earlier today in assembly language, which is driving me crazy because I wanted to input my number in binary format, ones and zeros, and it wouldn't let me. It had to be in hex, or not hex, it could be in decimal. But what it stored in the register was in hex. So if you're sitting there trying to analyze a problem in a program and you're looking at the register, unless it's just this one architecture, since it's in hex, you have to know how to convert that.
I got a quick question for you.
Okay.
I sent something to the printer from that lab. Do you know where it goes?
There's a copier up front.
Yeah, it didn't go there.
Oh, then
It goes, huh? Okay.
I don't know where they got it.
Thank you.
Mm-hmm. Actually, probably the printer's broke. It's funny because the copier printer we got here is not a great one. It's the one we had in Mulvane before they closed down that small building there. They did, yeah. And we got that, and I'm thinking, all right, we got a new copier. And I went to print something one time, and I need to use the staples, and there's no staples on it. And I'm sitting here. This is the printer I had back at. So it followed me. And it's funny because we got this here, and I'm thinking, oh, it's a brand new printer and so forth. At one point in time, we had printers that looked exactly like that in our offices at Mulvane. So I'm wondering if those didn't go into storage, and now they've worked back to where I got it again. They never could figure out at Mulvane, and they're a lot better now. Our network people now are really good, so I give them that. But the old network people we had could not figure out how to configure an IP printer so we could print from it from our desktop. And I'm not sure why they couldn't figure it out, because I've configured many of these to print to that printer. So, but like I say, our network people now are top of the line. So their solution was they just took the printers away from us. And they said, you can't use them anymore. That's not a solution. This is floating point numbers. Of course, we've talked about that, where you got decimals and so forth. Conversion specifiers, E and big E, are a floating point values in exponential notation, scientific notation. Typically, the way that's expressed if I got a, let's see, I guess they said floating point, didn't they? 500.37, give something like that. and E. The scientific notation says you have one digit and then the decimal place. So what it did, it moved this decimal place 3 places to the left. And that's why there's a plus, or there's an E plus E plus 003 here to indicate it moved the decimal 3 places. And then typically, oh, that is strange. I didn't expect it to drop the last digit. I'm sure it's still here, just the way it's displaying it. Okay, it's just ignoring all of those. So maybe by default it goes to six decimal places, maybe. Those are things you'd want to be aware of if you're writing a program where precision matters and you need to print it to the screen. Let's see if it says anything about 6. It's represented this way. Scientific notation is this way. E stands for exponent. Fixed point, F is not supported in the Visual C++ compiler. Let's try G. Display floating point in either floating point format F or the exponential format E based on the magnitude of the value. Assuming I haven't exceeded the limits. See here, I put it in the scientific notation or exponential notation because the number's so big. But if I have it small, like 50, then this puts as 50. So again, different options you have. I really don't use a whole lot of these because I don't write things where I need to control them a whole lot. There's just a few I use. So, let's see. The F always prints at least one digit to the left of the decimal point. E and big E print lowercase e and uppercase e, respectively. G or big G prints E with those. Okay, talk about that. I can go over all those rules they have for that. You can read the book for that. When outputting data, be sure that the user is aware of situations in which data may be imprecise due to formatting, rounding errors from specifying precisions. Like that problem, the one I ran where it rounded 6 decimal places. If engineers need it to 10, then obviously that's an issue, isn't it? Big E, little e, and G cause the value to be rounded in the output, and the conversion specifier %F does not. That was the one where, remember, it took it to 6 decimal places? It rounded it. And this shows, these are probably the best. If you look in the book and you look at these figures here and the output, that'd give a good idea of figuring out, which one should you use type of deal. Strings and characters. The C and S are used to print individual characters and strings, respectively. Conversion specifier C is a character, and S refers to a pointer to a character as an argument. And conversion specifier S causes character to be printed until a terminating null/0 character is involved. So that's our string, basically. So C for character, S for string. And they give the example here. You got your character, which is just a single letter, A. You got your brackets on here. This is going to be an array of characters, and they set equal to this as a string. By default, that /0 is included on there, so you don't have to put it on there at that point. And then here, we got a pointer to this is also a string. And then you see the different ones there. The %C just prints the letter. %S, and all three of these prints the string. So different ways of doing that. Don't use %C to print a string, because %C is for a character. %S to print a character argument often causes a fatal execution time access called access violation. Because the %S is expecting either a string, an array of characters, or it's expecting to see that /0, terminating. So it's not expecting a character. So. Using single quotes around a character strings is a syntax error. Character strings must be enclosed in double quotes. You'll find different programming languages have different requirements on that, so you just have to try one and see if you don't remember. Using double quotes around a constant character creates a pointer to a string consisting of two characters, the second of which is a terminating null. What they're referring to there is where you got that, which is a character, versus this right here. The double quotes indicates that it's an array of characters, and automatically puts the second one as that /0. Other conversion specifiers, percent or P. %P prints the value of the pointer and the address of X. These values are identical because the pointer is assigned the address of X. Last printf statement uses %% to print the % character in a character string. So here, %% is what they're talking about. Because normally a % says, hey, okay, the next letter or the next character is going to indicate like what type it is, a decimal integer, a floating point, maybe indicate rounding. And so if you just want actually just 1% appearing on there, just not as a specifier, but just to indicate %, and that's how you do it. You see it puts % there. Sometimes you have to do that for other special characters. Like a slash indicates the next letter is going to tell me something, like new line. So if I actually want to put a slash there, and I don't know if I remember this or not, but like // I think. Let's see. Yeah, see how it puts a slash there? So same type of concept here, the %%. Let's talk about that. The conversion specifier P displays an address in an implementation defined manner. On many systems, hexadecimal notation is used rather than decimal notation. Suspend. Where's suspend? Suspend. When you're working closer to the hardware level, I don't think I have an error there. Go away. Suspend. Are you sure I want to suspend it? Okay, it's still working, I guess. Okay, so if I were to run this, see over here these 0 X's? That's what I was talking about. That represents hex. So shouldn't have been a surprise to me that X is how you would represent hex in C. But specifically down here in our memory, if you're examining memory, the memory locations is in hex format. So that's what we're talking about here. If you're looking at memory address, decimal is probably not going to do you much good because the tools you'll use need to be in, the hex. There's a reason why they torture you with that class where you learn all that, like WinHex. If you look at the binary behind that, it's in hexadecimal format. So when you look at all this, then that's the format it's in. If you're editing a file, you cannot edit it in decimal format. It has to be in hex. That ASCII chart I've shown you. Although they include the decimal equivalents on there, you'll see that there's a column for the hex. There's also a column for octal. So again, hex is a big one in computers. I said you might never see octal because I'm not sure if it's actually used very much in computers or electronics. Hex is the big one, and binary. Okay. Trying to print a literal using percent rather than a percent is an issue because it thinks it should be followed by a letter, for like a conversion. P displays a pointer value. Percent displays a percent character. I don't know why I keep saying that over and over. But see how this is printing the 002 EF778. I don't know if this package would let you actually go to a memory address. Let's see. I'm going to copy this. INT asterisk pointer. INT asterisk pointer. INT x equals 10. And the address printf, the address is %p /n/n, and there. And let's see, int num scanf %d. Hopefully I got the right syntax there. So let's run that. The address is 006. Zero zero six 0 FF 08. Okay, now if I go over this Kyle, or how do we say this, Keel emulator package, let me go to the memory, see if I can go there. It might not, because sometimes when you run programs in Windows, it creates like a kind of a secure environment where other programs can't access that memory. And I don't know how this one works, so we'll see. 0FF08. Okay, so I went to that memory location. Let me go back one. 6. Yeah. See how when I'm gone here, what I should see is the value 10 in that memory location. 10, remember, in hex is A, isn't it? But as I look here, I don't see any A. Again, it either must have gave back the memory, or well, let me stop that. And let me start it again. Zero zero 6 0 FF 8. Yeah, I don't see an A there. So again, it probably wraps it somewhat, but that's the idea behind that. Is that if I'm working with a memory location here, I should be able to go to this memory location and see the value. And you can in here. Like if I change a memory location, I can examine it. Over here, probably if I printed the value at that memory location, I'd see the 10. So does that make sense on the? Okay. Now I know it seems weird. It's like, well, I thought you said computers ran on a series of ones and zeros, and now you're saying everything's hex. Ones and zeros wouldn't be so meaningful on the screen. Just a bunch of those, but the hex gives you something a little bit better you can work with. And there we go. Got the field width, and like if you do %4D, then that allocates the width of that integer. That comes in nice if you're trying to create some kind of report. You can have things line up. Like if I did a printf %d/n 1, printf %d/n of 1000, and printf %d of 30,000. Then it lines up that way. But if I come here and put my 1, 2, 3, 4, 5, see how it's right aligned? So by default, it's left aligned, and you do the %5, and it would be right aligned. So again, if you want it to look a certain way on a report or on the screen, that's how you can do it. Again, not providing a large enough field width causes the issues. and probably other problems too. I ran across this this morning, I think it was. Well, I swear I put in a value bigger than 32,000 something, and percent D or the decimal integer didn't like it. So, but I must be wrong. Different packages have different limits for that. Guessing that'll exceed the. See how it gives me a negative this. So you just need to be aware of what limits do you have on those variables, and if possible, if you're going to exceed them. And this shows doing different percent fours and what they do and so forth, especially the numbers. Does that look right aligned to you? No, it doesn't, does it? Because they use 4, and this has 5 digits. For the negative, looks good until it gets down here. And we get it, but again, with the negative and those 4 digits, there's 5 total, isn't there? Which again, they put 4 in here. So again, you have to plan that accordingly. Printf allows you to specify the precision. We've seen that already, I think. That's where if I have a floating point, the number is equal to 3.14159. Not that I can actually remember this. Is it percent %F? I always have to look these up. Some of them I remember. Percent %D is real common. Let's see. 3.14159. Why is that D there? I don't know why that D's there. It's not there anymore. 3.141590. You can put the 0.2 there. And that rounds it to 2 decimal places. You could put a number in front of there, like 5. And so then I run it. And you can't really see it very well, but there's an extra space in front of there to account for, that indicating as 5. So just different ways you can format numbers. Let me give you the example here. The percent 0.4D. I have no clue what that does. I would have thought that the dot 4 would round it to 4 decimal places, but there is no decimal places with an integer. But what it did is it put zeros on there, if you notice. So again, different ways you can format it, putting the leading zeros in front of it. Sometimes they require that in certain work, because they don't want there to be any kind of confusion. If it's supposed to be 4 digits, you put a 0 there, people know automatically by looking at it's 873 versus typing 8,730. It isn't around too much anymore. I bet if I look for jobs in it, there would be minimal amount. There's a programming language called Fortran. popular back in the 50s, 60s. You see there's 48 positions in it. Fortran was such that everything had to be, if I remember right, I think it was in groups of 4 digits. So you couldn't have 3 digits, it had to be 4. And so by putting a 0 there in front of it, you ensured that it was 4 digits. Let's see if I'm lying. It's been a while since I wrote a program for that. Fortran numbers in groups of 4. Maybe it's even numbers. Because it looks like 2 and 4 is what they're putting there. There was something to do with that. We were sending data from our Oracle system over to a product called Man. And so he had to have the data in blocked like that. Couldn't have like three characters. It had to be 4 characters. So we had to put that leading 0 on it and so forth. So you may sit there and wonder, why in the world would I ever want to do that? Well, there's times when you would need to do that. So, of course, I don't think we didn't write it in C, so I don't remember how we did that, to be honest. They got rid of the Man system. They replaced it with SAP. And now they're replacing that with Oracle ERP. And I really haven't even read very much about Oracle ERP. They just spent like $1 million on their SAP system. But they got bought out again, and that company uses Oracle ERP. So 9,638 jobs want you to know that. How about SAP? Less, 4,100. So maybe Oracle ERP is more popular for tracking manufacturing. Let's see. 9.3F displays 123.457, so it's rounded 3 decimal places, with 3 digits to the right of decimal point, right justified in a 9-digit field. Now, as bizarre as it seems, if you, maybe I haven't tried this in C, but if I had like that right there in front, the 5 indicates it should be a length of 5, right? But I have 5 digits alone just in front of the decimal. Let's see what that does. I think it ignores it and still puts 88,823. If I remember right. It does. So it doesn't destroy that number in front of it, but it's no longer a width of 5, is it? So just something to be aware of. I fully expected the first time I saw that and I played with it, I expected it to destroy part of the number. I cut it off. Here's where you can pass in the precision as separate, so you don't hard code it. So instead of doing %7.2, you put asterisks there, and you put 7 and 2 as parameters passed into the printf. Minus, left justify the output within a specified field. A plus displays a plus sign preceding positive values and a minus sign preceding the negative values. Space prints a space before that. Pound prefix 0 to the output value when used with the octal conversion specifier. And this is what they're talking about here with the I don't remember the little dash, the little negative, being left justified. Yeah, it is. Dash is left justified. Okay, never mind. Then this other one is just %10s and it right justifies it. So just different ways you can do justification. You're probably not going to remember all this, these codes, and all the exact details on it. The important part is remembering that the format specifiers controls it. So then when you try and figure out how to left justify something, I come over here, go to Google, type C programming format specifiers. This is what assuming I can spell. And I want to know how to do a left align a number. Had to pick the appropriate one. But here it says the specifier %-10d will display an integer left justified in a 10 character space. So then after I get that, I come over here, integer 512, printf, and it tells me to do a %-10d/n of assuming I'd actually done that correctly. Let's try it again. Num equals 512. Of course, there's spaces here, so I really can't see it very well, but left justified it, didn't it? Now, I would have done that anyway, probably. Like if I got rid of that right there, left justified it anyway, didn't it? Let me put an asterisk there. See how it gave the spaces here at the end, though? Bad example for me to Google, but you get the idea. You just look up whatever you're trying to do. Okay. It shows what that does. The plus there, the positive. Looks like if you do the percent plus, and you got 786, it'll put a plus on there. If you don't have the plus there, it just puts 786. So if you always want to have a sign, then that's how you do that. Looks like here, if you do a percent space D, then if you got a positive number or a negative number, it right aligns them like that. So it puts a space before the 547. So, I know it seems minor, but sometimes printing a report here is challenging. If you're in Excel, you just click the right align button. If you're in Word, you just, you have total control. Here, you don't have that control. And I don't know if I can come up with something. IP config. Imagine if this wasn't formatted. If this wasn't all starting in the same column, if there wasn't line breaks here, if it was all, in like one big paragraph, it wouldn't be easy to follow along. And having these line up for your addresses helps you to tell the different parts of it. I don't know if they got any that don't line up like that. See, they did not line these up, did they? Because they figured it wouldn't be such a big deal, I guess. But if I wanted to, I could format that with these specifiers if I put the right amount of time into it. Okay. And this is just printing in octal, printing in some hex, I guess. The pound flag to prefix a 0 to the octal value, assuming that's a 0 and not an O. And then 0x, and I think that's an uppercase X, to the hexadecimal values, and to force a decimal point on a value printed with G. So, again, some more specifiers. These making sense? Kind of boring, but not all programming is exciting. Here they do a plus. That'll print a plus if it's positive. If it's negative, you wouldn't have a plus, of course. And then it has 0, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 digits there. By putting a 0 there, it, instead of putting spaces there, it puts leading zeros. So down here there is no plus, so it just puts leading zeros, and it puts one more 0 than the one above it. Now, I never programmed, everything I did was pretty well at the Windows side, so I'd return something to a text box on a GUI form. I didn't really print to DOS. It's not quite true, but for the most part it was. We set up these little manufacturing stations, diskless workstations, and it was running DOS, basically. There was no GUI to it because there was no hard drive on them. They were booting off the network, and so they needed very bare minimum of everything. And I didn't actually write that program now that I'm saying this. I configured it. It was set up such that you configured it like ask the prompt. They should give the user what kind of field it was. Was it a number? Is it a string? And then it stored it off in the database. So I guess I really didn't even do the formatting there. But it was DOS based like that. Again, this is talking about some of the escape sequences, how to print quotation marks. Print a single quote, you do slash single quote. Print a double quote, you do slash double quote. To do your audible bell, you do your slash A. We looked at that last time, or time before. New page or form feed. Slash in is new line. We saw that. Carriage return. Move the cursor to the beginning of the current line. That's kind of a weird one. So if I do a printf, hello everybody, slash R. If I run that, There it goes. See how it's still sitting on that first H?
Okay.
That's what that does. I put a 3 in there, and it does the scanf part. I had to get it so it wouldn't actually kick off. And you're sitting there, why in the world would you want to do that? Well, I'd want to do that so I could print some other letters over these right here. What? So if I ran this, see it overwrote hello. Weird things, and you may not see the need for it right away. A lot of it is geared toward printing to printers, because you don't got a nice Windows package, Word, Excel. You can print formatted documents over to that. You're having to send special characters, special codes, and so forth. And so these are the weird things you have to do with printers. At least that's where I ran across them. 3. Moves the next horizontal tab. Moves the next vertical tab. Moves the cursor back 1 position on the current line. That's a /B. So I could have this right here. I could have that right there, and I won't go to the next line there. But then I could have a for int x equals 0, continue while x is less than or equal to 4, x plus plus, printf, percent, is it percent or slash? Slash b. So went back for. Why would you do this again? When we were printing to those, they had special printers print off barcodes, and they were cheap ones because we didn't want to spend a lot of money on it. We could have bought a really nice printer to print these beautiful barcodes, but they didn't have to be that great of barcodes. Not everything has to be top of the line. Those are pretty good barcodes, but if I had something that didn't have to be a pretty good barcode, I sent it to the printer. You print it one time, it's not dark enough. Well, you could then go back so many spaces, print it again. Back up, print again. Third time you print it off, it's now dark enough to where the scanner will read it. So, yeah, there's reasons behind all these items. Let's see. That's probably all exciting stuff there. Precise input formatting can be accomplished with scanf. Every scanf document or statement contains a format control specifier that describes the format of the data to be input. By the way, this is like a pause I put in here, where you do a scanf and you don't do anything with it. That's so the program won't terminate. So it's sitting there waiting for something, a dummy value basically. But this is what it's talking about. You have to have your specifier here, %d, for example. Inputting all types of data, inputting specific characters from input stream, and so forth. There we go. Now here we are. %d reads an optionally signed decimal integer. %i reads an optionally signed decimal and or hexadecimal integer. I wonder how you specify a hexadecimal integer. Put A's in there maybe? Let's see. %i like that. then I'll print out the value of it. So printf %d/n num. This would be A1. That's in hex. That'd be A, which is 10, times 16 to the first. So that'd be 16 plus 1 should be 17. Assuming my math is correct. Not even close. 29. How in the world do they get that? $16 to the 0, which is 1. 1 times 1 is 1. This is 16 to the first, which is 16 times A, which is 10. That's 160. 161. I may not be understanding the format it's saving it in. This actually saves as 29. Oh, I bet %x is what I need to do. So A1. Is that what I said it should be? Yeah, 161. What in the world was I then? Read an optionally signed decimal, octal, or hexadecimal integer. I still don't know how in the world you'd tell it a hexadecimal integer then. But anyway, let's see. HL, we talked about those. A lot of these are the same as they are in the printf as they are in the scanf. So not much difference there. Let's see, floating point. How in the world do you read a floating point value? Well, let me try. (3E05). 1, 2, 3, 4, 5. Okay. So you can put it in scientific notation, because that was one of the ones listed. We haven't looked at that before. But if I want to put in 3 times 10 to the 5th power, that's 3E05. C is for a character, S is for a string. And again, it says that it has to be large enough to have the terminating /0 in it. Oops, what was that last one? I didn't see it. Scan characters. Scan a string for a set of characters stored in an array. P, an address. N is the number of characters input so far. Percent, skip a % sign in input. %I can input hexadecimal. That's one I tried to do, but I think I recognize what I did wrong. (0x) and what did I put last time? A1, 161. I didn't put the 0x on there. I don't know what octal was. Do you remember octal? Was it C? Yeah. But if I knew the character to put in for octal, then I could input it in that format. Now that took me a little while to learn. Because at first, when I started teaching this assembly language class, I saw this the %x, and I'm thinking that's part of the address. This was the very first time, and then I finally came to realize that that's not the hex. Because I was wondering, well, that's kind of weird. Why are they putting that on there? X is not even one of the hex characters. It has to be A through G or whatever I told you. F was it? Okay. Let's see, A, B, C, D, E, F. Yeah, F. And this shows just reading in a bunch of integers, and then printing them. So you don't have to have just one per line. You can have 1, 2, 3, 4, 7. So you can read on all 7 at once. Putting 0x before the hex. 70 in hex, that's like 7 times 16 to the first, plus 0 times 16 to the 0. 7 times 16 is 112? Yeah, 112. Why in the world is that coming up with 56? Oh, because it's looking for different formats. %C, %S we've talked about. They're just saying it applies equally to scanf. Now here they got %8, and then they got AEIOU inside of brackets, and we're reading that into Z. Z is our array of characters. We don't need the little symbol there because by default, the array of characters is a pointer. They input all this 00 EE 00 AH, and it keeps the 00 EE 00 A. Why did it do that? I don't think I know myself. I may have to go back and read that. Okay. This figure uses that scan input stream for vowels. Note that the first 7 letters of the input are, because the last one is a /0, isn't it? Because I'm sitting there, why isn't there 8 there? And okay, that makes sense. Note the first 7 letters input are red. The 8th letter is H is not in the scan set, and therefore the scanning is terminated. Well, no, it just terminates when it runs across the first one that's not in that list. So that's why it had nothing to do with the /0, I guess. But yeah, this would have read in 8 letters, but since it ran in one that's not in the list, that's where it stopped and dropped all the rest. Scan set can also be used to scan for characters not contained by the inverted scan set. To create an inverted scan set, place a caret in the square brackets before the scan characters. And they give the example here where we put that in there. And so when it prints string, when it runs across an I, that's one you can't have, and so it just prints str. In this example, see how they did the %2D and then %D? That %2 indicated that the first 2 numbers were going to go in that first variable. And then all the rest went into the next variable. And you see they entered in 1, 2, 3, 4, 5, 6, and then 1, 2 was in the first variable x, and 3, 4, 5, 6 was in the second variable y. Often it's necessary to skip certain characters in the input stream. For example, date could be entered with the dashes here. Each number and date needs to be stored, but the dashes should be discarded. To eliminate unnecessary characters, include them in the format control. So, for example, to skip the dashes in the input, use this statement where you put the dashes there. Looks like they're using the %C to indicate any character, because that's what they're talking about over here. The %C conversion specifier indicated the character appearing in the input stream should be read and discarded, because they said the problem is you could put dashes in between them, but you could also put a slash between your month, day, and year. And either way, you want to discard those extra characters. So again, you do that with the actually, they got a %*C. Doesn't say anything about the asterisk. If I had to guess, I'm guessing it's if you had more than one character. Like you had slash, it would ignore it. This just shows if you put a dash or you put a slash, it gets rid of those extra characters. Now, secure C programming. The C standard lists many cases in which using incorrect library function arguments can result in undefined behaviors. These can cause security vulnerabilities, so they should be avoided. Such problems can occur when using printf or one of its variants, such as sprintf, fprintf, printf_s, etc. The certification cert rule, FIO00-C, discusses these issues, presents a table showing valid combinations of formatting flags, length modifiers, and conversion specified characters can be used to form conversion specifications. I was just curious if you had to pay for it. C coding standard. I bet this is an exciting document. In this online download, the root causes common software vulnerabilities. Did I click it?
So that one, the free C standard.
Good eye. Oh, I don't want to sign up. But you could download that and read about the standard they've come up with to Again, the idea is there's so much hacking going on, and most of it's people based. You either got your employees giving out information they shouldn't be, or you got programmers writing poor programs. So it's all based around people screwing up. Now you might say, well, hardware's secure then, right? No, because everything on a hardware is being run by programs. They're lower level programs. You got assembler programs running. You got really low level like this, but it's still programs that people are writing. Table also shows the proper argument type for each valid conversion specification. In general, as you study any programming language, if the language specification says that doing something can lead to undefined behavior, avoid doing it to prevent security vulnerabilities. That's all of that chapter. It's too early to let you go. Let's start talking about chapter 10. I won't get too far into it because I don't want to split the section up between the time frames and so forth. But we'll talk about a little bit of these items. Chapter 10, you got C structures, unions, bit manipulation, and numerations. We just covered bit manipulation in assembly language. Not sure why you do it in C, but we'll see. Objectives: create and use structures, unions, and numerations. Pass structures to functions by value and by reference. Use typedefs to create aliases for existing type names. Manipulate data with bitwise operators. Create bit fields for storing data compactly. There's an overview of the sections. And we got something called structures. It's a way of arranging data. This is an example of a structure. Structure card, and then you got character, and then asterisk face, a character asterisk suit. Here's a more full example. Structure employee, and then you got character first name 2020, character last name 20, unsigned integer age, character gender, double hourly salary, and then you end the structure. Now, the question is, where do you put that at? Let's see, is where there's code. Got to be kidding me. Not one code example. There's structure is above the main. Okay. So to create a structure up here, let's say we're going to create an employee. And semicolon or curly brace. There we go. And we have the salary. This is where we're defining our different variables. Now this down here, to create an instance of it, thinking in terms of objects, you do structure card, which matches that name, and then what you want to call it. So structure employee David. Now notice down here that we can refer to that name and then dot and then the variable name. So David dot salary is equal to 50,000. Now let's see if I forgot anything. Doesn't like structure spelled out. It must be just struct. Yeah. There we go. I should have recognized it because it didn't change the color. Okay, so no errors. Now, printf %d /n and then comma David dot salary. Zero. %d. Why did I do %d? %f. Why do I want double? Float. There's 50,000. And you can define whatever up here. I think they had, I'm not sure if they had this bracket on this or the F name. I'll see. Let me do L name. And let me check, see if there's any errors. Okay, it's not there. Yeah, still got an error. Let's see where it's at. Number. Input the number. 20. In name. Last name. So then down here, David dot last name equals to Hayes. Printf %s /n David dot last name. Dot last name equals. Oh, not. No, that should be fine. Unless this should be single quotes. Try that. Multi-character constant assignment to expression with array type. Let's see if they give how to do that. Because I just wanted to hard code it. I didn't want to do get S or anything. Okay, so I got to define as a pointer in order to use the double quotes. Okay, let's try that again then. Come up here, define as a pointer. There it goes. So again, this is you go through and you define your structure. And then I like to think of this down here as creating instances of that. So I could have another employee like Frank. Now you wouldn't actually hard code these in like this. You'd probably put like employee 1 like that, employee 2 here. Employee 1. I was programming before there was a replace all. Whatever, I'm sitting there typing it all in. I don't know why I was typing it all in. See, it works still. So again, to create a second employee, we do this right here. And then we can assign different things for the second employee. This is structures is kind of like the precursor to object-oriented programming. Have I mentioned object-oriented programming in here? Yeah. You go on Walmart, and let's say I'm going to Walmart. I'm going to steal some stuff tonight. Tomorrow, I'll go in there tomorrow when there's a lot of people in there. Steal some stuff. They got scanners at the door that catch most of the the expensive stuff. But I'm sure if I put a packet of Starburst, in my pocket and walked out, they wouldn't catch me. I bought a bag over there during lunch, and she asked me if I paid for it. Of course, she asked me if I wanted to put in a bag. She made a joke, do you want a bag in the bag? And I said no, that's fine. And I had my little receipt out, because I'm not used to trusting people. So I expected to be thrown against the wall and, where's my receipt type of deal, like they do in Wichita. And the guy wasn't even turned around. This was like I could just walked out with the bag to begin with, but it probably had some kind of scanner on there or some device. But they got cameras up in the ceiling watching. Well, when you got 200 people walking around Walmart, how many people would they need to watch everybody? 200. Watch you close. Because the minute I'm watching somebody else could be when you're putting something in your pocket, right? Now maybe if I watch somebody a third of the time, maybe I'll catch them doing something suspicious. Maybe their actions, they're looking around type of deal. Maybe that would cause me to, really trigger into somebody. But you obviously can't have 200 people watching all those cameras. One way, if you're thinking down the road, 10 years from now when artificial intelligence becomes a little bit more, somebody walks into Walmart. Your computer program creates an instance of them. This is customer 1. And it'll sit there and monitor and watch it. And then if something suspicious happens, like you pick up something and you put it in your pocket, then that senses that you just shoplifted type of deal. So then you don't have to have 200 employees watching your 200 customers. You can have one computerized program that's creating these instances of a customer. Does that make sense on where this would be kind of used? Now you can do an array of structures too, and I probably couldn't get this right. But down here, let's see if I can figure out how to put it. Brackets here, maybe. There's only 3 places it could be. Obviously not there. Of course, I didn't put the size, did I? Let's try that. Obviously not there. Not there. Maybe you even have to do it different for structures. There it goes. So now I don't have to have employee 1, employee 2. I got an array defined. And I can use indexing to do this instead. This is like the card example. If you want to use an array of, the structure, what should a suit have? Well, it should have, the face card, and numbers, right? So you need to specify those somehow, and maybe whether they're still in the deck or not. So maybe you have a variable here indicating whether they've been pulled or not. This is if you're trying to create a card game in text-based mode. That's really about all I want to get there. I just wanted to introduce the idea of a structure because there's quite a bit here in this. This is a harder section. Next week we're not going to have class. I don't think we'll have class. I'm going to go ahead and plan that. Because if I don't, there's no way I'm going to have time to create the recording prior to the class. So this weekend I'm going to create a YouTube video where I go over examples and so forth and do this. And I'll put it out there along with a project. Now, if things are going well, and I will get online. So if you're having trouble with any program, I only put one out there for this week. And I'd be shocked if you have any trouble with it. But, I'll get on there and work examples again, answer any questions and so forth. But do not show up here, though. Do that from home and so forth. Now, I will. I'm not going to be the first one running out. So if you're struggling with something, use this time to your advantage. I don't have anywhere to go. But I am going to take a break before I answer any questions you have. So. But if you don't have any questions, feel free to take off. But otherwise, I'll be back shortly. I get sitting too long. I have to get up. Was there any questions on anything? Don't have any? Well, I'll go ahead and stop the recording then. And I'll be here, like I say, so if you have questions, stick around.